Yeah, this works fine as the previous circuit, right? This works fine as a switch capacitor integrator. But we have some problem here. Yeah, previous switch capacitor integrator circuit was this. See, I have a switch here. It may be a CMOS transmission gate. I just draw NMOS switch for simplicity. So I just draw this one in a single-ended version for simplicity. You can implement it in a fully differential version. Yeah, the drawback of this circuit is just parasitic capacitance. It's included. Yeah, we have some junction capacitor there. We have some interconnect capacitor there. You know, when this during pi1 phase, this capacitor voltage, this charge here is C1 plus C stray. Stray includes the junction capacitor and interconnect capacitor, V in some T, right? Yeah, during pi2 phase, this entire charge is dumped into C2. So my VOT will be yeah, just added this one. See, for in the previous example, this is my VOT will be yeah, my V in times this C1 plus C stray over C2, right? This C stray, yeah, you know, we have some unpredictable result because the integrated gain becomes changes by C stray. Besides, this C stray may be voltage dependent. I mean nonlinear. It will generate some distortion, right? So that's no good. We have a good one. Stray insensitive. Okay, this one is stray insensitive. Switch the capacitor integrator. We have 4 switches, right? Instead of 2. That C1 is not grounded capacitor. It is a floated capacitor, right? Floating capacitor. None of the ground is connected to ground, right? So it is a floated capacitor, and also 4 switches. Yeah, in this case, say, let's look at it. During pi1, let's see. Let's look at the pi2 first. So during pi2 phase, yeah, M2 and the M4 are on. Those switches are off, right? So you know C1, those C stray, they are all discharged to 0 during pi2 phase. Yeah, all 3 capacitors are discharged to 0. It means all the charges on those capacitors are set to 0. Okay? Yeah, during pi1 phase, what happens? Yeah, pi1 phase. Yeah, those M2, M4 are turned off, and then M1, M3 are turned on, right? So in this case, say, yeah, I assume actually this is 1.65. This is, I assume a DC input, 1.75 volt DC. Yeah, by negative feedback by C2, this node will be virtual ground, 1.65 volt, okay? Then, suddenly, this Vin is connected to Cin, then, assume this was 0 volt, right, initially, because C1 was discharged during the preceding by 2 phase, okay? Then, you know, just after this Vin is connected, 1.75 volt is connected to this one, this voltage will be shifted to 1.75 volt instantaneously, right? Because C1 voltage is 0. C1 charge is 0. Then this voltage will drop drastically in a negative direction. Then it will try to flow current to change VO into negative direction. So there will be large current flows through this capacitor, right? It must go through here, here, here. So it will, this current flows from this Vin source, and then it will increase this C1 charge, okay? Yeah, when this C1 charge, Q1 becomes C1 times 0.1 volt, then this voltage comes back to 1.75 volt again, okay? Then, you know, this goes to the steady state. Then virtual ground established again, all right? Yeah, during this by 1 phase, the left-hand side become charged to C1, Q1, right-hand side of C1 is charged to minus Q1, and then, you know, because this charge C, this left-hand side of C2 is also charged to Q1. I mean, it's incremented to Q1. So, yeah. So see, at the end of by 1 phase, so this is, I am assume this is NT. So I'm defining time like that. So this is by 1, right? So I'm assuming this is T equal NT. This equal T equal N minus 1T. Okay. I have by 2 also here. So my by 2 is just this one, right? I assume this time point is n minus 0.5 t, okay? Yeah, this is my t, period. So I will compare this C2 voltage between this time point and the previous by 1 phase time point, okay? So here's, I can say my BOT, actually this is a charge. C2 BOT is my charge, right? C2 BOT minus 1.65 is my charge. This is actually Q2. This is Q2. Okay, this is Q2. At the actually this NT, T equal NT. Okay, C2 VO NT minus 1.65. That's my Q2 charge. This is that charge is N minus 1T minus 1.65 volt, and then there was a negative contribution, right? Minus C1 V in what? V in, yeah, NT. So let me write it again. Oops. So in this stray insensitive, oh, actually we didn't talk about the stray insensitive yet. Okay, let's go back. So this NT, this is actually Q2 charge. is Q2 charge in the previous by one phase minus C1 V in NT. Okay? This will be my integration equation. Question? Okay. So here, stray insensitive circuit. Why this becomes stray insensitive? Okay, let's look at this. So, because see, during by two phase, all those three capacitors are completely discharged. Okay, so during by one phase, see this is V in. Let me change color. So during by one phase, say this C1 will be charged to what? C1 V in, and this charge will be minus C1 V in. There is a charge will be added there. Okay, how about those charges? This charge will be C1 V in. Is it right? Yeah. And this charge, let me see. This charge will be, initially it will be charged to C1 V in. Finally, it will go to 0. Because at the end of by one phase, there is a virtual ground will be established here. And then this voltage will be 0. So this is turns on. This voltage will be 0 again. Okay? So, you know, for this CTS2, this charge was 0 at the end of by one phase. And after going, it can be non-zero in between, and it will go back to 0 at the end of by one phase. Okay? So the beginning charge, starting charge, and the ending charge is same for CTS2. So this doesn't contribute to charge flow into C2. How about this one? Yeah, it will be charged to some non-zero value, V in T. However, this charge flow comes through here. It doesn't contribute to C2. So in this charge flowing into C2, it is independent of both stray capacitance. Okay? So that's why it is stray insensitive. Question? Nope. Okay. So the previous one is inverting switched capacitor integrator. This is the inverting version. Yeah, see, if I connect by one, by two, that way, it is an inverting integrator. This C1 will be charged dumped into C1 V in, minus C1 V in. This V1, the charge will be added in that way. However, if I change this one, see, this by one, this is by one, by two, then see, the charge will be dumped into opposite polarity. Then it becomes a non-inverting integrator. Okay. Yeah, see, here is there is during by two phase. Yeah, during by two phase. Those two are on, right? This is on. This is on. So the left hand side charge will be plus C1 V in. This right hand charge will be minus C1 V in. And then during by two phase, by one phase, it will be connected that way. So this minus C1 V in will move here, and then there is a plus C1 V in developed there. So when this is completely discharged, then this is a 0, right? Then I have a virtual ground again, okay? So because this is positive, this is inverting integrator. Sorry, non-inverting integrator. Question? Nope.